July 2026, 14 o'clock. In modern conflicts, one piece of technology has changed the way the world thinks about aerial observation. Small, fast, and remarkably agile, FPV drones have evolved from a hobby into a highly capable platform for reconnaissance, inspection, filmmaking, and defense research. Today, we take you inside the world of Ukrainian FPV drones to understand why this technology has attracted global attention. Unlike traditional camera drones, FPV aircraft place the operator inside the flight experience. Wearing special video goggles, pilots receive a live view directly from the camera mounted on the drone. This first-person perspective allows them to navigate complex environments with extraordinary precision. The technology itself is surprisingly compact. A lightweight frame, high-speed brushless motors, a flight controller, an FPV camera, and a low-latency video link. When combined, these components create a highly responsive aircraft capable of flying through challenging terrain. FPV pilots spend hours practicing before they ever fly a real drone. Many begin with flight simulators to develop muscle memory, improve reaction time, and learn how to maintain stable control in a wide range of conditions. THESE training methods help reduce mistakes and build consistency. As FPV technology continues to advance, new communication systems, improved batteries, and more efficient cameras are expanding what these small aircraft can do. Researchers and engineers around the world are continually testing new designs to improve reliability and performance. The rapid development of FPV drones is shaping the future of aerial technology. What began as a niche community has grown into a global field of research, engineering, and professional application. In the next chapter, we'll explore how Ukraine's FPV ecosystem evolved and why IT has become a focal point for defense analysts around the world. As the demand for FPV drones grew, small workshops rapidly expanded into larger production facilities. Engineers continued to refine frames, improve flight stability, and develop more durable designs. The speed of innovation has been remarkable, with new ideas emerging far faster than in many traditional technology sectors. Modern FPV drones are designed to be highly modular. If a component fails, IT can often be replaced quickly without rebuilding the entire system. This modular approach has helped drive rapid experimentation and continuous improvement. Camera technology has also evolved significantly. Modern FPV cameras can operate in a wide range of lighting conditions, providing clearer images and improving situational awareness for the operator. Battery technology continues to improve year after year. Higher energy density, better power management, and more efficient motors have helped extend flight performance in many applications. Operators also spend time reviewing recorded flights. By analyzing previous missions, they identify areas for improvement, refine flight paths, and build experience for future operations. This process of continuous learning has become a key part of FPV development. The story of FPV drones is not just about machines. IT is also about engineers, developers, pilots, and researchers who continue to push the limits of what small unmanned aircraft can achieve. In the next chapter, we'll look at how emerging technologies like AI, advanced sensors, and new communication methods are shaping the future of FPV systems. The next stage of FPV drone development is nitrogen monoxide. Longer just about speed, IT is about intelligence. Engineers are now exploring new ways to help drones navigate more accurately, maintain stable flight, and operate more reliably in challenging environments. Modern drones rely on a combination of sensors to understand their surroundings. Cameras, GPS receivers, IMU modules, and barometers work together to help maintain stability and provide the pilot with accurate information. Software has become just as important as hardware. Open-source flight controllers, regular firmware updates, and active developer communities have helped accelerate innovation around the world. Another important trend is miniaturization. Components are becoming smaller, lighter, and more powerful. This allows drones to carry better cameras and fly more efficiently while remaining highly maneuverable. The rapid growth of the FPV industry has also created new opportunities outside the defense sector. FPV drones are now used for filmmaking, infrastructure inspection, agriculture, search and rescue training, and scientific research. The story of FPV drones continues to evolve. What started as a small community of enthusiasts has grown into a global technology movement. With new ideas emerging every year, the next generation of drones may look very different from the systems we see today.